Welcome, everyone, and thank you for joining us for today's webinar hosted by the American Geosciences Institute in partnership with MyNASA Data. My name is Lindsay Mosa, and I'm an education specialist with the American Geosciences Institute. AGI and NASA have had a long history of working together to bring earth science into classrooms and learning environments. That partnership has been especially strong through Earth Science Week, where NASA and MyNASA Data have helped us provide educators with engaging, authentic resources that connect students with the science happening all around them and with the data scientists use to understand our planet. Over the years, this collaboration has resulted in a wealth of classroom activities, data based investigations, and other educational resources. My NASA Data, in particular, has developed tools that make authentic NASA Earth science data accessible and useful for educators and students. The Earth System Data Explorer, which will be looked at today, is a great example of this. It allows learners to explore and visualize more than 60 NASA datasets through maps, graphs, comparisons, and data tables. Today, we're going to take a closer look at resources developed around the Earth System Data Explorer. And with that, I'd like to turn things over to Angie Rizzi from MyNASA Data, who will share these resources with us.
Hello, I'm Angie Rizzi, and I am the task lead for the MyNASA Data website and Earth System Data Explorer tool. I'm really excited to be here with you, and I appreciate the opportunity to share our resources. I invite you to reach out to me at the generic email on our website at any time if you have any questions or need any follow-up information. In this session, I'll give you an overview of the MyNASA Data website, including an introduction to our data literacy cubes, and then I will spend the majority of the time on a demonstration of the Earth System Data Explorer, which is our data visualization tool. MyNASA Data provides educators, students, and facilitators with accessible and usable authentic NASA Earth data. The project is led out of the NASA Langley Research Center Science Directorate. We incorporate real NASA satellite data to offer valuable learning experiences which empower learners with the resources to access and efficiently use the authentic data. These resources are organized in a variety of different ways, and they are also scaffolded. We have fully curated resources which include different types of lessons, such as mini lessons, lesson plans, interactives, and 5E story maps. We also have flexible and customizable resources, such as our data literacy cubes, and we have our Earth System Data Explorer, which supports inquiry-based investigations. And finally, we have connecting resources, including STEM career connections and globe connections. This scaffolding allows multiple entry points into the NASA data and opportunities to develop data literacy skills while also learning science content, with the easiest being the fully curated resources and the ability to do open-ended inquiry with data in the Earth System Data Explorer. The landing page highlights the organization of the Earth system data by Earth as a system. We have drop downs for different spheres in the Earth system, including atmosphere, biosphere, cryosphere, geosphere, hydrosphere, and Earth as a system. All the content is aligned to next generation science standards, but can also be used outside formal classrooms. We will explore the geosphere today. There will be a page about the geosphere and phenomena for each sphere. Today, I would like to pull up the volcanic eruptions phenomenon to show you how the curated resources are organized. The page for a phenomenon will include a description of that phenomenon, as well as a link saying read more to a page that has a lot more information about that phenomenon. In addition, around the middle of the screen, you will see links for the curated content, mini lessons, interactives, or lesson plans. It will default to the mini lessons, and they will be listed below. These are going to be short lessons that have a couple questions, and students or learners can engage with them. The interactives will include our 5E story maps and sometimes shorter interactives. A 5E story map is written using the education framework of engage, explore, explain, elaborate, and evaluate. When you click on a story map, it will bring you up to a page for the educator, which will have additional resources that are not in the actual ArcGIS story map, such as forms or pages for students to work on. To access the story map, you will click on the link on the teacher page and you will be taken to an ArcGIS story map. I will pull up the Explore section of this one to demonstrate what we mean by interactive. And one part of this includes an interactive map of volcano locations where learners can click on a location of a volcano, find the plate that it's on, and find additional information. That is a very quick demonstration of a story map. The lesson plan page will list longer lessons and activities, and you can see that there will be more than one lesson for the phenomenon. Returning back to the top of the page, I will point out that at the top of every page is a search box. You can enter in a search criteria at any time, and you will be taken to the faceted search page. This will allow you to filter by grade band, time, sphere, phenomena, resource type, and the 3 dimensions of the next generation science standards, as well as Common Core math and technology requirements. This is a very powerful and helpful tool. Okay, that was a whirlwind tour of the website, which did not include everything. One of those things is the data literacy cubes that I promised to introduce. I'm going to show you an edited video about the cubes.
Welcome to the Data Literacy Cube Guide, a MyNASA data tool for differentiated learning in earth science. This video is brought to you by NASA Langley Research Center in Hampton, Virginia. Data literate students are able to explore and make sense of data to explain events and phenomena in the Earth system. Depending upon the student's developmental level, data exploration and sense-making will look differently at the elementary, middle, and high school level. While there are many forms of data, ranging from qualitative facts used to form approximations to quantitative datasets that are more common in the sciences, it might be difficult for students to jump into their data analysis. Data literacy is a skill that is developed over time with repetition. The analysis prompts included with the Data Literacy Cube guides provide students with a set of steps to help them recognize patterns, relate cause and effect, observe stability and change, and much more. Let us begin by opening up the MyNASA Data webpage and navigating to Resources, and then to Data Literacy Cube Guide. This will take you to the main Data Literacy Cube Guide page. Under the image of the cubes, we see a link where we can download a PDF document of the Data Literacy Cube Guide. This guide provides the resources needed to implement data literacy cubes in an in-person and virtual classroom setting. You will notice the icons frequently used in the guide and on the MyNASA Data website. These include one for maps, one for line graphs, and one for use with the data tables. The icons shown indicate the compatibility of MyNASA data content to the data literacy cubes. These tools are aligned with the next generation science standards and Common Core mathematics standards. Opening the PDF, we can see a complete overview of the steps needed, a cube template, the task card, the question sheets ranging from level 1 to level 4, and the keywords included at the beginning of most question sheets. Teachers are able to differentiate their instruction using the question sheets.
I hope you enjoyed that video, and as it demonstrated, the cubes can be used for analyzing different sorts of data. They're most popular with the map data. And all of those types of data representations are available in our Earth System Data Explorer. And we'll get into that in a little bit, but we do have some curated maps that people can use with the cubes, and those are called our Earth System satellite images. And we have 6 lesson plans that we've put together that incorporate the mapped images and the cubes. Those include analyzing one image or annual changes in a variable, relationships between 2 variables, relationships among all the variables for a particular month, or looking at all variables for all months. You can also look at one variable over a year, use the legend, estimate the values, and graph the 6 points. So it's a simple, only graphing 6 points, but having to use that skill of estimating. So whether you want to use a pre-made lesson plan with the cubes, or if you just want to use the cubes, the Earth System satellite images are currently for the year 2024, and we have 6 different Earth System variables. Each of the variables has an image, which is a global image, for every other month in a year. So there are 6 images for each variable over the course of the year. The variables are the monthly flow of energy into the surface by shortwave radiation, which is basically visible sunlight. We also have normalized difference vegetation index. Think of that as a green up, green down kind of indicator, looking at the health of vegetation. We have the monthly surface skin temperature, which is actually the temperature of the ground. And we have cloud cover, aerosol optical depth, and precipitation rate. So let's look at an example. We'll look at NDVI, or Normalized Difference Vegetation Index. NDVI is important because it helps us monitor the health of vegetation, monitor ecosystems for disturbances, determine where vegetation is thriving and where it's under stress. This quantity measures the health of plants on Earth's surface, and it looks at different radiation reflections and is a ratio which has no units. This is important when we get to the cubes because there are some questions about units. And from a data literacy perspective, an answer of no unit can be an important thing for learners to be aware of. So I'll walk you through an example of how the leveled questions work. On the NDVI image for January of 2024, the global image shows the data for that month, and the legend allows you to see the approximate values. If a user were to roll a 3, the novice level questions that they would have to answer would be about the color at each end of the legend and what that means and what the number means. And that would give them an opportunity to begin to unpack what the colors and numbers on the legend meant, which of those were healthy and which were not, as far as NDVI, and maybe even to talk about the fact that there's no unit. The next level would be progressing, and they would start to answer questions about the highest values showing up on different areas of the map and the lowest areas and talking about what they mean. Moving on to level 3, which is proficient, it starts with the pattern that they might observe and what changes and similarities they observe by latitude and longitude and what they believe might cause that. And finally, moving to level 4, which is advanced. The questions are about patterns for high and low values and just a little review. What time frame does the map represent? So that gives you an example of how the levels progress in terms of the complexity of interpreting the map. Returning to the full-size image from January of 2024, I'll show all 6 of the images fairly quickly so that it is like an animation of the changes over the course of the year. And this is a great way to look at the changes over a year, in addition to the lesson plan I spoke of earlier. Other things you can do are to compare single images. In this case, I'm looking at January 24 compared to July of 24. And there are certainly some differences that are apparent by the relative amounts of brown and green in the images. And those are things that can foster conversation and exploration. You can also look at different variables for the same month in the same year. And in this example shows the monthly surface skin temperature, again, the surface on the ground, to the monthly normalized difference vegetation index. And this might lead people to ask questions about maybe different types of land cover or that type of thing. So with that, I will say that these global images are great. They're already curated for you, especially looking over the course of a whole year. There are lots of interesting things that can be explored. But a lot of times people want to look at their own area. They want to look at a much smaller region, local data, and that's where the Earth System Data Explorer comes in. To access the Earth System Data Explorer from the main page, you can hover over Visualize Data and then select Earth System Data Explorer from the menu. The Earth System Data Explorer page will load, and you can use the plus and minus buttons to zoom in and out. There are some different options available on the right. The default is white. You can also select satellite to see true color satellite imagery, as well as map. And the map has a terrain option as well, which is easier to see if you zoom in and pan. At this time, I will go back to the default white, and I will zoom back out and move the map. So I mentioned earlier that sometimes looking at the surface skin temperature compared to NDVI prompts questions about land cover type. So I'm going to pull up a land cover data set to start with. So our data are organized by Earth System Sphere. I'm going to find land cover under Geosphere. I will select the category Land Use and Land Cover Change. And I'm going to select the Land Cover Classification Global Dataset, which is from MODIS, and I will choose the year 2021. The name of the dataset and the date selected will appear on the left, along with the legend. Notice that the legend is different this time because it's categorical data, and so it's color-coded with the descriptions. You can change to grayscale palette if you would like to see it without those colors. You can do this for any data set, and you can always switch back to color. The description of the data set on the left tries to describe it in everyday language. And one of the most important aspects is it tells you the grid spacing. This data is on a 500-meter grid, and it is the global data. And the data comes from MODIS. You might notice that it appears that there are missing data, and that is because it's out over the ocean, and this is land cover classification. Learners might need to be reminded that's not really a mistake. Another feature that can be very helpful when interpreting the legend and the colors is to use the identify function on the right. That allows you to probe data. So not only is it good for finding data values, it's good for interpreting colors. So if I want to click on a particular color, I'm not sure perhaps which one this is, I can click on the location. The map will center on that location and there will be a black dot there. The latitude and longitude will be filled in, and you will see that that is sand, rock, and soil, and you can see the color over here in the legend. I'll exit that tool as we do any time that we are finished doing something on the right. So another analysis tool that is available is to do a compare to swipe. This tool allows two data sets to be compared by using a slider. Before I select the second data set, I'd like to pull up the satellite imagery, and we can compare the data set to the satellite imagery to see if there's anything that we notice. I've switched back to white so that we can select another data set and easily see the data. I'm going to select the same data set from Geosphere, Land Use and Land Cover Change, Land Cover Classification Global, but I'm going to select a different year. In this case, 2001. The new data set loads on the right-hand side, and the old one is on the left. And the slider will allow us to see differences. This is a pretty good resolution, and so we don't necessarily see huge differences on the country scale, but we can zoom in on a location. I'm going to type in the query Las Vegas and select that location to zoom in, and we see that we have the two data sets. When I move the slider to the left and expose the map on the right-hand side, we are looking at 2001. When I move the slider to the right to expose the map on the left, we're looking at 2021. Notice that there are some differences in the urban and built-up lands on these maps. Now, because I think it's really interesting, I want to select a different data set. And this is a land cover classification data set for only the continental United States. It has fewer years of availability, and I'm going to select 2021, which is the same as the map on the left. Remember, we're looking at Las Vegas still. Notice that the legends for each map are different. The colors are not the same for the same categories. This might be tricky, but it's a great data literacy exercise for learners. This would be another reason that we might want to use the identify feature. But as we compare these two for the same year, notice that there's a lot of agreement, and then maybe some areas that are slightly different, because if you notice, the data set on the left has a 500-meter grid, and the data set on the right has only a 30-meter grid, so it is even more detailed. So these are some interesting things that we can do to look at land cover classification in MyNASA data. Like all the tools that we use on the right-hand side, when we're finished, we need to exit the tool. The data set from the left-hand side will be the one that continues to be displayed. Now I want to enter into the side-by-side tool. This tool is similar to the Compare to Swipe, but instead of using a slider, it will load the two images next to each other. To improve my context, I'm going to zoom back out to verify where I am. And I will select the data set for the right-hand side, which is going to again be Geosphere, Land Use and Land Use Change, the Global Land Cover Classification for 2001. So I'm comparing 2001 and 2022 to see if I notice any differences. I do note some differences in this area for certain. And I invite you to think about which of these views is easier for you to interpret. When might one of these views be more useful than another for you? So I will exit the side-by-side tool. So we've looked at Compare to, Swipe, Identify, and Side-by-Side, which are analysis tools that are available for all of our data sets, including the categorical data such as land cover. The Generate Download Image is also available for all data sets, and I'll review that in a bit. But I want to show you that if we select a data set that is not a categorical data set, we will have some additional options. Back on the left-hand side, I want to change over now. I'm in Geosphere, and I'm going to change to skin temperature, and I want to look at the monthly surface skin temperature. I'm going to select August of 2024 and zoom out. So this data set is from AIRS. It is 1 degree latitude by 1 degree longitude, which is not nearly as high a resolution as the land cover data sets that we were looking at, but it is good to give us patterns, things like seasonal change and that type of thing. And I want you to note the legend here. So the hottest temperatures are represented on this map by yellow and not red. That is something that it often takes learners some time to interpret correctly, and that is one of the things that the cubes helps with. So we have the same options of Compare to, Swipe, Identify, and Side-by-Side, but we also have a time plot and a scatter plot option available to us, as well as 2 data download options for our numeric data. I would like to start with the time plot option. The first thing that we need to do is enter a location. We can type it in, or we can click a location on the map. If you choose to type in latitude and longitude at any time using the Earth System Data Explorer, we use positive numbers for north and east and negative numbers for south and west. If I click a location, that location will be centered on the map and a black dot will appear. You can then select your date range, and I am going to select 2011 January through 2015 15 December. And I will generate the plot. Notice that the map, which is the date selected on the left-hand side, is centered in a smaller version below a graph. The graph has the axes labeled. Time is on the x-axis, and in this case, we have degrees Celsius on the y. We have the title, and we have the latitude and longitude. And if I hover over the individual points, I will get pop-up windows that tell me what those values are. There's a little button in the top right-hand corner of the graph. I can click this button to pop it out to a large version. And at the same time, I can still scroll over the individual points to see the values. And most notably, I can download a PNG. So by clicking on the download PNG button, I can download an image that can be used for projects. It can be used for developing lessons, anything that you would find it to be useful for. Going back, you may notice that step 3 here, which is optional, allows you to add a second variable. So I'm going to select this option by clicking on the box, and I have some data set selection criteria that appear below. That allows me to select the second data set. In this case, I'm going to select geosphere, skin temperature again, and this time I'm going to select the monthly surface air temperature, and I will generate the plot. I'm going to pop this out because we've already seen how to do that. And in this case, we have a double line plot. The surface air temperature is the solid line. The surface skin temperature is the dashed line. And please note that on this graph, we have two y-axes. Okay, so the skin temperature is on the right and the air temperature is on the left, and they do not necessarily have the same scale. From a data literacy point of view, this can be a difficult thing for some people because in this case, it looks like we have air temperature that is warmer than skin temperature. The average monthly surface air temperature for July of 2011 was 30.769. And for this average surface skin temperature for the same month was 32.47. A quick glance at the graph may not lead you to believe that the skin temperature was warmer than the air temperature. So this is a definite data literacy function. The reason the tool works this way is because not all double line plots are comparing variables with the same units, and so they need their own axes. However, if I exit the time plot, I'll show you a tool that can help you with this if you want to look at the data in a different way. There's an option for a time series data table. With this option, you can select a location. I'm not necessarily going to pick exactly the same one. I can select my date range. I will go with January of 2021 through December of 2024 for fun, and I'm going to add one variable. And I will select geosphere, skin temperature, monthly surface air temperature, and generate a data table. You will see, if I pop this out, that we have a table now that has more than one variable in it. They are all for the same location, and we have the monthly surface skin temperature as well as the monthly surface air temperature. We can download the CSV file and take this into any other data program that we would like. And in this case, because we have the same unit of degrees Celsius, you could plot them on the same axis and it could be a little easier, and that would be a way to scaffold data literacy skills. You can add up to 3 additional variables, so you can download up to 4 variables at a time. So I will exit this tool. Another graphing option that we have is a scatter plot. So I'm going to select the scatter plot tool. Again, I will choose a location. I will go back to 2011 January through 2024 December, and I have to choose a second variable in order to do the scatter plot, which makes sense. So I will select the same data set that we've been working with, which is the surface air temperature, and I will add a trend line and the equation with the R-squared value. These are optional, but I will generate the plot. And again, we have the mini map below the graph. If I pop it out, it's even easier for me to see all of these things are available. If I hover over the line, I get my equation, and I can download this PNG as well. Remember that we also looked at the data download function, and you could download the data and do your own analysis in a different program as well. So I'm going to exit the scatter plot function. So I'm back to all the tools that are available to me, and I now want to show you how to use the Create Your Own Data Table option. This option is going to allow you to select locations for the variable that you have chosen on the left-hand side, and you can also change the times. So this one is one variable only for different locations and possibly different times, where the other option for the time series data table is always the same location, but it's up to 4 different variables. So if I select the option to create your own data table, it may recenter the map, and you will see the directions displayed on the right-hand side. At this time, the option is to click on different locations. Coming soon, we will have the ability to enter in different locations. So I'm going to pan back over to the United States, and I'm going to select a location. I will click on the location, and there will be a mini map below the table that is starting to be built at the top. And you will see that there's one row added to the table up above. As I click on additional locations, the black dot will move and new rows will be added to the table. So notice that these are all for August of 2024, which is the same date we originally selected for our data set. I'm now going to change it to January of 2024. The mini map will change. And if I select the same location that I just selected, you will see that there's now a row for January of 2024. And the location is very close to the location. It might be slightly different because I may not have clicked exactly the same spot, which is why we will be adding the feature to enter in your own latitude and longitude. I'll select one more location for January. You see now 2 rows in the table, and I'll pop the table out so that you have a better view. And here we have only one variable, monthly surface skin temperature, various dates, August and January of 2024, and you see the different latitudes and longitudes, and the download CSV button has appeared. You can click that button in order to download the data and take it into any other platform where you might want to use it. So I'm going to exit this tool as well. Finally, the last data download option is to generate a download image. So if I click the button, the tool will generate a link which will be displayed, and you can then click the link to download the image. The image will appear on your screen, and you can then save it. On a PC, I would right-click and save it to my device. So we've spent a lot of time looking at land cover classification and surface skin temperature today, but I want to point out to you that we do have many other data sets. One thing you can do to find them is simply explore through the different spheres and categories to see what's available. Some data sets are repeated in different categories if it makes sense for them to be there. But we also have a link to our dataset citations page. This page will give you the actual data citations if you are using this for projects or anything where you need to provide attribution. We ask that you please do this. From here, you can also get to our data collections page, and this page will list all the different data sets that we have. It will show which categories they're included in, which spheres, and the start and end dates for the data sets, because they're not all the same depending on the availability of the data from the various missions. We also have a link to our tutorial page here, so you can find tutorials on more. I know that we went quickly, and if you need to find more information, please do that. And finally, we do have a reset button. If you want to start over for any reason, that's a good way to start. Also, do not hesitate to reach out to us at any time. We're always here to help. I hope you've enjoyed this presentation, and I look forward to hearing from you soon. Thank you.
Thank you, Angie, for sharing these resources and showing us some of the ways the Earth System Data Explorer can help students work with authentic Earth science data. And thank you to everyone who joined us today. We hope you've come away with some new ideas and resources you can use with your learners. And don't forget that this webinar is just one part of the long-running collaboration between NASA, MyNASA Data, AGI, and Earth Science Week. Use these links to access lessons and activities to get your students engaged with the Earth Systems Data Explorer, in addition to resources created through Earth Science Week that are housed on the online toolkit and the classroom activities collection, which includes dozens of activities that analyze Earth data collected by NASA. We encourage you to explore these resources and share them with your colleagues. Thanks again for watching.